Let's solve the equation y triple prime minus 2y double prime plus y prime equals 0. Because I don't see any independent variables, I'm just going to consider that my function, it's a function of x, so the independent variable, even if it's not written, it's x. So how do we solve this kind of equations? Well, the type of the solution that we expect to have is of the form e to rx. So y prime of x is going to be r e to rx, y double prime of x is going to be r squared e to rx, and y triple prime of x is going to be r cubed e to rx. So when we replace this into our equation, let's call it star, we're going to get r cubed e to rx minus 2 r squared e to rx plus r e to rx equals 0. But e to rx can be factored out, so we end up with r cubed minus 2r squared plus r equals 0, and since e to rx cannot be 0, we end up with the equation r cubed minus 2r squared plus r equals 0, which is called the characteristic equation, and we usually skip all these steps, and just by reading the equation, when we see y triple prime, we usually replace with r cubed, because when we differentiate a solution of this format, we end up with the term or with the factor r cubed. And then 2y double prime ends up being minus 2r squared, and y prime is going to be the plus r. So this is a cubic equation, and we can solve it for r by factoring out r. So r squared minus 2r plus 1 equals 0, or r times, and we know that this one, it's a perfect square, it's r minus 1 squared equals 0. So we end up with r equals 0, and we end up with r equals 1, double solution. So then our answer, our solution to the homogeneous third order differential equation is c1 e to 0t, right, this, plus c2 e to 1t, or 1 times t, and then because it's a double solution, it's going to be plus c3t. Oh, sorry, I changed my variable. It's y of x, so it's 0x, and then 1 times x, and then c3x e to x. So basically, y of x equals c1 plus c2 e to x plus c3 x e to the x. The general solution, or the solution to the homogeneous equation star.